Okay, let's talk about the ray node. The ray node is a pretty important node that we will use throughout the course for all kinds of things. But in its core, what it's doing is it takes the points of one geometry, looks for the closest surface on another geometry, and moves the point there. So how does that work? So here's a very simple example. We have a sphere on one side and a grid on the other, and we drop a ray node, and it has two inputs. The first one is the one we want to change, so we want to change the grid, and the second one is the one we want to change it by. So what's happening now is this. And what's happening by default is it is set to project rays of the normals. So it means it looks into the direction of the normals and finds the closest position on the surface of the second object, the sphere. Now, we don't have the attribute normals yet, but there's kind of an internal automatic normal that it uses when you have a geometry, and it looks in this direction, and the points that find something in this direction move to that. That also means that if you move the grid now, you can see that when we move it into the center, then the closest points they find in this direction of the normals is this side of the sphere, and when you move it outwards, it doesn't find anything. Now you can change the behavior of this by changing the ray from project rays to minimum distance. And what happens now is it moves all the points that were here before to the closest point on the surface of the sphere. And this is why the whole grid kind of moved onto the surface. And this depends on the surface position and the grid position as well, what happens. So this is kind of interesting because it doesn't look just in the direction of the normals, but always it finds the closest point on the surface, which sometimes can look a bit weird. Now there are multiple things you can use this for. For example, what you could take is you could take a sphere like we just had, and we take a box inside of that sphere, something like this. And by using a ray node, by default, nothing happens because the normals of the sphere are outwards. But if I switch it to minimum distance, what happens now is that the topology of the sphere now changed its shape to the box because it moved all points to the closest point on the surface of the box. So this can be an interesting way of turning one object into the shape of another. Now in this case it works quite easily. In more complex cases, unfortunately, you will not always get what you want. So for example, for a toy, even though the result here is correct, it's not necessarily what you might expect. So be careful, it's not necessarily always giving you what you want. Now, how can I use this in practical terms? An example I found is, for example, we have something like a Zeppelin here, and let's say we wanted to have some, ropes around or something. It would be quite annoying to do this by hand, so let's try to use the ray node for that. And for this, I created a ring by using a circle and then turning it to polygon and switching it to open arc, and now we have just a curve with 24 divisions. There they are. And then I use a copy and transform to copy this a couple of times around the Zeppelin. So if I take a ray node now, by default in this case it will not work because there are no normals that are calculated on the curve automatically. So what I have to change is I change it from project rays to minimum distance, and now you can see that the curve is kind of sticking to the surface of the Zeppelin, which is really cool. Now in this case I also have here down here the part where the passengers are in, so it's not perfect. So let's quickly separate just the balloon, and I do it this way. I select by 3D connected geometry, and then I select the balloon, press delete, so I create a blast, and then I invert that, and then I only have my rings around that. And something we will see later, but I want to quickly do it. There's a sweep node that I can use to turn those curves. And by the way, you can turn off the guide geometry if that bothers you by turning off the show guide geometry, and then we only see the result. And the sweep node allows you to turn those curves into geometry rings. And if I merge this with my original Zeppelin, you can see what we got out of this, which would be pretty annoying to do this by hand, but with this ray node, it's actually quite straightforward and easy to change later on. So another thing we could do is we can use that for a simple ground example. Here we have a ground, just a grid with enough resolution, and then a mountain node on top. And then I take a toy, for, let's say, and then I use array node. And by default, the points on the grid will look upwards in the direction of their normals. There they are. And find all the surface points on the toy. So that looks a bit weird, but you can also reverse that. So let's reverse the rays, and then it looks downwards. And that means if I move my toy down, you can see what happens. We basically have something that pushes, let's turn off the toy for a second. It pushes the geometry down of the grid, and it looks like we kind of stamped the toy in, which also of course works with simpler geometry and a bit easier to see. So here we can push things down as long as we reverse the direction of the normal so that it looks downwards. And this is a great way of, you know, creating footsteps in snow, and this is actually something we will do later on. Now, sometimes you don't want to rely on the normals alone, and let's say we have, you know, a hill or something, and we want to use this toy and move the snow downwards and not to the side, because even if I reverse the rays right now, you can see that it moves them in the direction of the opposite normals. Now, for a case like that, you can also change the direction from normal to any kind of attribute if you have a vector attribute you want to use as a direction, or you can change it to vector, and now you can define your own vector. Now, by default, it already has, that's why it's green, an expression in it that reads out the normals. So it's kind of the same as before, but I can delete this expression by right-clicking and then choose delete channels, or how I would do it with the hotkey next to it, Control, Shift, and left mouse button, because it's much quicker. There you go. And now I can define my own direction. Let's make sure I don't reverse arrays, and I look downwards, which means, of course, it's 0, -1, 0. And now you can see I can define my own direction. The ground here should look towards to find the closest point on the second input. So yeah, so finally, you should also know that you cannot only do all this with geometry. Let's take this example, for example, but you can also do this with points. So if I just scatter a bunch of points on the surface of my grid and then use the ray, then you can see it works just the same way. So we can do the same thing with normal points, not just geometry, which technically in Houdini is the same anyway. Just one last thing, if you switch it to project rays, then keep in mind that points by default don't have normals calculated because they have no direction. But you can do this by just creating a normal node before the scatter node coming from the grid, because then you can calculate them on the points, the normal attribute. There it is. And this will then be inherited by the scatter node to the points, and now they have the same normals, and now they will look in the direction of the normals before, and then it looks like this, and even the points will find the surface in a certain direction, and you can do all kinds of things with points as well. So as you can see, the ray node is very versatile. You can do a lot of things with this, and we will do quite a lot of other things during the course. So play around with this and get a feel for it, because it's a pretty powerful node. So I hope this is helpful. Thanks very much and see you later. Cheers.